Hello everyone, and welcome back to 30 Days of Java. It's day 4 now, and today we'll be discussing about the user inputs and memory type. Our agenda for this video would be how to take user inputs, defining constants and literals, how variables are stored in memory, and what's heap or stack memory. We'll also be implementing these topics in IntelliJ for practical understanding. So let's begin. In Java, you can take user input using the scanner class, which is a part of java.util package. In this example, we first create a scanner object named scanner to read input from the standard input stream, system.in. We then prompt the user to enter their name using system.out.print and use scanner.nextLine to read the entire line of input. Let's try this out in IntelliJ now. First, we'll need to create a scanner object. So type in scanner to new scanner and then system.in. Now we'll prompt the user to enter his name. So we'll type it system.out.println and then enter your name. Now we'll use the scanner.nextLine to read the entire line of input and store that in a local variable. So we'll type string name equal to scanner.nextLine. Now here, scanner.nextLine would read the entire line of input, and then it would store that value into name variable. Finally, we display a greeting message that includes the user input. So we'll type in system.out.println and then hello. Now let's try to run it. As you can see here in the console, it's asking me for my name. So I'll type in GoldenCat. And here you can see that it showed me a greeting message saying hello GoldenCat. It's using the input value that we just passed into its final greeting message. Also, it's important to note that after using the scanner, it's a good practice to close it to prevent resource leaks. So for closing that, we'll type in scanner.close. Now this is a basic example, and you can use different methods of the scanner class depending on the type of input you are expecting. For example, next int, next double for numeric inputs. Suppose if I also want to take the user's age as an input, I can do that using scanner class. So I'll type in system.out.println and then enter your age. For storing the age, it should be a numeric value. So for that, we'll use an integer variable. The name of the variable should be age, and now we'll use scanner.nextInt. Now that we have the age, we can just modify this final message to also incorporate age in it. So we'll type in plus your age is age. Now if I run the program again, first it asks me for my name. So I'll type in GoldenCat. And now for my age. So let's type in 25. And here it is, saying hello GoldenCat, your age is 25. In Java, constant and literals are used to represent fixed values in your code. Let's discuss each concept. Constants are variables whose value cannot be changed during the execution of the program. In Java, you can declare constants using the final keyword. Conventionally, Constant names are written in uppercase letters. Literals are representation of fixed values in your code. They can be of various types, such as integers, floating point number, characters, strings, etc. In the example, 14 is an integer literal, 3.14 is a floating point literal, A is a character literal, and hello world is a string literal. Let's try to implement this all on IntelliJ now. Let's first start with declaring and initializing a constant variable. So we'll type in final int and then capital X equal to, let's give it a value of 15. Now we'll also declare another variable which is not a constant one. So we'll type in int y equal to, let's just give it a value of 20. Now suppose if I want to change the value of y variable, I can do that easily. I can just type in y equal to 30. And now y variable would hold the value of 30 instead of 20. But if I change the value of x variable, Java compiler wouldn't allow me to do so. Suppose if I type in capital X equal to, let's just say 50, it would give me a compile time error. If I hover over the red line, you can see it's showing me an error message which says cannot assign a value to the final variable x. A constant variable cannot change its value throughout the runtime duration of the program. Now that we are aware of the different data types and variables, let's discuss about how they are stored in memory. In the table here, the first row represents the memory cells and the second row represents their respective memory addresses. As we have already discussed that a character variable takes 2 bytes of memory. It takes 2 cells, since one cell represents 1 byte. Integer variable takes 4 bytes of memory. It captures 4 cells. And same logic is followed by other data types like floating point, which takes 8 bytes of memory. In Java, memory is divided into 2 main areas, the stack and the heap. These areas serve different purposes and have different characteristics. The stack memory is primarily used for storing local variables and managing method call information. Variables in the stack have a short lifetime. They are created when a method is called and destroyed when method exits. The size of the stack memory is typically much smaller compared to the heap, and access to variables in stack is fast because memory allocation and deallocation are simple and quick. The heap memory, on the other hand, is used for dynamic allocation of memory during the runtime of a Java program. Objects in the heap can live beyond the scope of the method that created them. They are only reclaimed by the garbage collector when there are no more references to them. As we move forward with our course, these distinctions will become more and more clearer to you. As always, we'll end our video with a quote which says, "You have power over your mind, not outside events. Realize this and you will find true strength." Thank you for watching and have a great day.